In this projectile problem, we have some golfer right here who hits a golf ball with some initial velocity and at some angle. And we're asked to figure out this distance that the golf ball travels, and this distance is somehow on an angle. The angle that this fairway is at is 5 degrees. So what do we do first? Well, first we can break up this initial velocity into x and y components. So if we look at this initial velocity, right here we have 160 feet per second, and this can be broken up with a y component, so our v naught y, and we can have an x component. So right here is v naught x, and of course this angle right here is given and is 25 degrees. So what do we know? We know that v naught y is going to be equal to 160 times the sine of 25. And if we simplify that, we get 67.6 feet per second. And we also know that v naught x right here, is going to be equal to 160 times the cosine of 25. And this, when we multiply this out, we get 145 feet per second. So this is our initial velocity in the x direction and our initial velocity in the y direction. What else do we have to figure out? Well, we have to look at this total distance d that this ball travels. We know this total distance d right here also has a y component and an x component to it. If we look at the y component, it has to move down. So we're going to call where the ball starts our origin, or our 0, 0 point, and we're going to say that up is our positive y direction and to the right is our positive x direction. So this ball has to go downward, so it's a negative direction, and it has to move towards the right, which is a positive direction. So if we call this our y final, and we call this right here our x final, we want to come up with an expression for both of these. Well, our x final, and we do know that this angle right here is 5 degrees, so our x final is going to be equal to this d times the cosine of 5. And our y final is going to be equal to this right here. So it's going to be a negative number because it's going down, and it's also going to be d times the sine of 5. So this gives you the x and y components of the final position that the ball's at. And what we can do, if we write down everything else we know that it starts at an initial position of 0. It starts with the initial y of 0, and it has gravity. Gravity points down. Its acceleration is pointing down against our positive convention in its gravity. So our acceleration is gravity, and this is equal to minus 32.2 feet per second squared. And what we want to do is we want to look at these horizontal and vertical components and the equations that we have for each of them. So the equation we want to use for this horizontal component is that a final distance x is equal to an initial distance x naught plus velocity, initial x velocity times time. And we know most of these. We know everything except time. So if we look here, we have our final position in the x, which is this x final, and that's d cosine of 5, and that's equal to an initial x position, and what we just said, this was 0. And our velocity in the x direction is 145 feet per second times some time, and we don't know what time is, so we're going to solve for time, and time is going to be equal to d cosine of 5 divided by 145. Now if we look at our vertical direction, we have that a final vertical position is equal to an initial position in the y plus our initial y velocity times time plus 1/2 times the acceleration times t squared. And again, we know we have this, we have this, we have this. We just came up with an expression for time, and we know this, and we know this. So we do know everything for this equation. However, our y final position has this d in it. So what we can do is we can say that our y final position is minus d times the sine of 5. And this is equal to an initial position, which is 0, plus our initial velocity in the y direction, which is 67.6 times time. And we're going to substitute this equation in for time. So we have times d cosine of 5 divided by 145. And then we have our acceleration term, so it's going to be plus 1/2 times negative 32.2. And let's keep the colors consistent, and this time squared, we're going to substitute this term into it again. So we get times d cosine of 5 divided by 145 squared. And if we solve this equation right here, we're going to get that d is equal to 0 feet, or d is equal to 725.8 feet. And I solved this equation by putting it into a calculator and using my solve command, but you could solve it however you want. And we do know that, well, we have two answers. This is probably not the answer we want, because this means the ball doesn't get hit at all, which, I mean, could be possible if some people are golfing. But the answer that we're looking for is the ball goes this distance right here. The ball travels 725.8 feet.